So we at Linaro Connect, and so who are you?
Hi, my name is Amit Kucheria. I am the lead for the Power Management Working Group. I lead a fantastic group of engineers working to improve the power management infrastructure in the Linux kernel.
So does that mean that your work is going to extend the battery life on all ARM-powered devices?
Yes, it's going to improve the battery life. It's going to make it a lot easier for SoC vendors to configure their power management for the SoCs.
So is that one of the things, for example, Apple does well with their OS?
Yeah, they do a reasonably good job of it.
And is that something that, for example, the Android ecosystem is a little bit behind compared to Apple, or some of them are pretty good? Or?
So for a lot of the static use cases, I think Linux is almost as good as any of the, or even better in some cases than the commercial offerings. But on some of the runtime use cases, I think we could do a lot better job.
So how much better is it going to be? What kind of tricks are you working on to?
That's a hard question to answer. There's just so many things that you have to look at, and it is so use case dependent. But suffice it to say that for things like the common cases like web browsing, MP3 playback, any kind of media playback, I think we're not completely optimized yet. I think we can still do a much better job.
So what kind of things do you have a team you work with, and what kind of things are you working on?
Yeah, so I'm very lucky to work with very smart engineers from a lot of from all of our member companies. So I have engineers from TI, Freescale, Samsung, ST Ericsson, ARM, IBM, and some of the key areas that we are working on currently are around the Linux scheduler, and this is in preparation for asymmetric multiprocessing, the big little that people have been talking about lately, where basically the current Linux scheduler thinks that all cores are equal, which is true of every architecture out there. But with big little, you are going to have cores with more processing power, less processing power, and so you need to change the way the scheduler works there and takes the scheduling decisions, because the big one can now take more tasks than the little one. And that's one area that my team is working on. The other area is around CPU idle consolidation. So right now there's a lot of redundant code in the SoC specific drivers, which can be optimized away and moved to the core framework itself, so that the SoC specific drivers then just become data files with SoC specific latency tables. And so we are doing a lot of work around consolidating those drivers and creating library functions to save and do common things like save and restore register context and whatnot. And the third area that my team looks at is tools and debugging capability. So we make sure that the PowerTop tool that is available upstream works well on ARM. Similarly, we have a tool called Power Debug, which we use to debug the clocks and the regulators on the ARM SoCs and see what's on, what's off. Plus, we have a set of functional QA tests that we run to make sure that, and we've basically generated those tests to make sure that all these building blocks are in good shape, they're in working shape across our member platforms. We do daily tests on the builds, Linaro builds for these things.
So to have good battery life on a device, basically the software needs to be awesome. Is that how it works?
Yes, it has to be. Well, software is just one part of it. You also need to have good hardware design. As I covered in my talk earlier today, you could do lots of things with software and do hacks and special case tweaks to optimize for one use case, but that might not work for another use case. And sometimes you might just need a better hardware design to to your use time goals.
So it's a tight collaboration between the chip designers and the software idea havers?
It's chip designers, of course, but there is also the board designers who use that chip on the board and how they connect all the peripherals together. If they don't wire it up correctly so that you can idle things when they're not in use, then you're basically burning away power.
So before the big little chips are actually made in a foundry, and before the PCBs with the chips are made, you need to have all the ideas of software in place in before.
Luckily, a lot of that can be modeled very well with existing SMP systems. So some of these are very generic problems that need to be solved anyways. So what we are expecting is that using either fast models or some sort of emulation on existing systems, we should get to about 60 to 70% of the way there in preparation for the hardware. And once we have the hardware, then it'll be the last 30-40% that needs tuning. So that should reduce our effort after the hardware is available.
Do you sometimes have different groups of engineers going on different routes, and if you calculate how much power is used, then the one that wins is the one that uses less?
Yeah, you have to try out different. I mean, in a sense, our team does a lot of R&D as well, and sometimes that R&D is successful, other times it's not so successful, and so and sometimes you get two competing solutions, and you just pick which one looks better from a design perspective, from a maintainability perspective. So you just have to make those calls.
And the one that the losing team is not sad?
No, this is in open source. It's not about individual winnings or losings. It's about the best design winning. And I mean, if you are a kernel developer, you get used to the fact that when someone criticizes your patches, they're not criticizing you personally. They're criticizing that idea, or and they're probably giving you suggestions on how to improve it. And sometimes there's a lot of smart people out there. Not everyone works for the companies at this conference. So you have to take that with grace and basically be thankful for that great advice you get.
So one of the numbers of Big Little is 70% power saving. Is it real?
It's certainly possible. It's certainly possible on some of the use cases that ARM has modeled.
Compared to current CPUs?
Yeah, because the little processor basically consumes a lot less because of the way it's manufactured. The A7 microarchitecture, just by its design, will consume a lot less. And you could, and given current workloads, you could possibly move a lot of this stuff to the A7 and use the A15 cores only for really, really high performance tasks.
So the ARM processors of the future are actually going to use less power?
Yes.
For sure?
Yes.
So if it's been amazing so far, we have seen nothing yet in terms of
it's only going
low
to get
power
better.
in ARM.
It's going to get better.